Alright, so like the last video, I would recommend that you hit pause here, write down the problem, maybe give it a shot on your own with what you think maybe you're supposed to do, and then turn it back on when you're ready to see the work. We're looking at books here on the New York Times bestseller list, and we're comparing fiction and nonfiction books to each other. Okay, without even reading the problem, I can go straight to the null hypothesis being that the two means are equal to each other. Okay, if I go back and read through the words at the end, blah, 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 can we conclude that there is a difference in the mean times? Difference in the mean times means another two-tailed test right here. Yeah, I think I found one that wasn't on the next page. Now, my two sample sizes, what color do I want to use? There were 15 hardcover fiction books and 15 hardcover nonfiction books. Okay, so my degrees of freedom, if I subtract one from each sample size, I get 14. I pick the smaller of the two numbers, and so the smaller number between 14 and 14 is 14. So I have my degrees of freedom being 14. My level of significance is 0.10 here. And so I'm going to look on table F under a two-tailed test with alpha equals 0.10 and slide down to degrees of freedom 14. That tells me the two t-scores I'm working with are plus and minus 1.761. And if my test statistic ends up in either of these blue shaded regions, I'm going to reject the null hypothesis. Otherwise, I'm not. For my sample statistic, my test statistic that I'm going to compare to that rejection region, I'm going to subtract the two means of my two samples. Again, because I'm testing the hypothesis that they're actually equal to each other, the difference in the two means is 0 there. Now on the bottom, just like before, I have my standard deviations squared over the sample size. Here my standard deviations are sample standard deviations. I can't read my writing, 13.2. Okay, and both sample sizes were 15 here. So the top is nice, -6. On the bottom, I get 3.762. And that ratio is -1.595. When I compare that -1.595 to my cutoffs up here, notice that I'm on the right side of that -1.761, which means, I guess this is how I did it last time, I'm not in that rejection region. So I'm going to say do not reject the null hypothesis. There is not enough evidence or sufficient evidence. You can use that word. I think the author does. Use that one to support the claim that the mean number of weeks is different. I'm not in the rejection region, so I can't reject that null hypothesis. I can't say that there's really any difference in those population means. And that one was problem number 1 out of section 9.2, if you need to look in your textbook and compare. Okay, here's problem 8 from section 9.2. Pause the video, write it down, come back to me when you're ready. When we start by making our null and our alternative hypothesis, back to salaries. Salaries are a very, I think partly because ed majors have to take this class, so talking about money, for them it maybe makes sense, but also money is a very common thing that we study. Average salaries, average income, average, all of that. With the census this year, Okay. Even more popular. So we're testing in different school districts. Are those means the same? Okay. Or if we're reading the last line, I'm going to say, are the elementary salaries greater on average than the mean of the secondary school teachers? Okay, so if I want mean 1 to be elementary school, that's my population 1, and secondary school teachers, that's mean 2. Okay, that's my population 2. This time I'm testing to see, are my elementary averages bigger than my secondary averages? My sample sizes here are also different. I just lost them. And 1 is 26, and 2 is 24. So if I take 1 away from each sample, I've got 25 and 23. I choose the smaller of those, which gives me 23 degrees of freedom. My level of significance here is back to 0.05. And so I am looking, because of the greater than sign, I am looking at a right-tailed test. My first non-two-tailed test. A right-tailed test with degrees of freedom at 23, alpha equals 0.05, and I'm going to find out that t-score is 1.714. When I'm finding my test statistic to determine whether or not I'm in that shaded region, then I'm going to take the difference in the two means, which is 48, 256, minus 45, 633, minus 0. On the bottom, I've got $39.12.40. I like how this one goes to dollars and cents and the other one's just a whole number. I don't know if they did that on purpose or not. But here is 5533 squared over 24. On the top, I get 2623. On the bottom, I get 1365.4. And that ratio is 1.921. When I compare that 1.921 to my rejection region, I find out that it's inside there. It's to the right of 1.921. So I will say that I'm going to reject the null hypothesis. Okay. In this problem, there's sufficient evidence to support the claim. I'm getting lazy here. Support the claim that elementary schools teachers mean salaries are greater than secondary school teachers. Okay. We're saying on average, the population mean, if I look at all of the elementary school teachers and find their mean salary, it's going to be greater than the mean of all the secondary school teachers. Their salary. Right. Then, like before, we can move on and say, hey, look, this is the same problem, number 8. Find the 95% confidence interval for the difference in these means. Okay, now, this confidence interval is enormous, unless I pushed a button wrong on my calculator. So what we need to do is, at the bottom end, remember we have the difference in those means, which, again, since we've already found it, I'm just going to go straight there. Okay, then we need our t-score. times, remember I had that star and I had that red circle there. It's the stuff under the radical there, or the square root of that stuff, which is 1365.4. I'm actually just going to put plus and minus that. This t-score is not going to be 1.714. When we're finding confidence intervals, we have to, we're thinking of it as a two-tailed test where it both ends there. And so we're going to have 2.069 will be the t-score that you'll find. Degrees of freedom, 23, a two-tailed test for alpha equals 0.05. Okay. That tells me the low end of the difference of those means. Where did it go? Is a difference of $202. But the high end is 54.48. Okay, the difference of those means could be where one is greater than the other by over $5,000, or the other one is greater than the first by $202. Again, I don't know how useful or helpful it would be to find this confidence interval here. I just wanted to show you how to do one where, on an example, we'd already done all of the work, and we didn't have to go back through the nitty-gritty again. Again, remember that we're not using t equals 1.714 with the confidence interval. We always use the two-tail value there, or the confidence interval value at the top.